हेलो गाइस, मेरा नाम मोहम्मद इजहान खान है। Currently, I'm pursuing my degree in civil and environmental engineering from IIT Patna. So basically, we were solving the exemplar questions of continuity and differentiability for the past three classes. So now moving forward, so I think we have to start from question number 56 today. So let's see. In question number 56, it has been given to us that tan inverse x square plus y square is equals to a constant a, right? So what can we do? I can write it like this: x square plus y square is equals to tan a. Simple. Then right. So hmm, so this will be our answer. Now, we have to start from question number 60th, I think. I had done question number 60. I had to do question number 60 first. Okay. So question number 60 first, right? So in question number 61st, y is equals to cos raised to the power of cos raised to the power of cos and so on. So can you write it like this? If it is going till infinity, we can definitely write it like this. Then I'll ask you to take the log of it. So upon taking the log y is equals to y log cos x. Differentiating dy by dx. Chain rule here, dy by dx log cos x plus y upon cos x. Differentiation of cos x is minus sin x. All right. So now 1 upon y minus log of cos x dy by dx is equals to minus y tan x. So dy by dx and 1 minus y log cos x and this is y. So this will be your dy by dx. So moving forward with these proven questions, you should try them yourselves. Okay, these are not very relevant kind of questions. They are just you have to invest your time in them. So do it yourselves. Moving forward with question number 64, you'll learn something out of this. So y equal to tan inverse x dy by dx is equals to 1 plus x square. All right. Now d2y by dx square 1 plus x square raised to the power of 2 Differentiation of 1 will be differentiation of this will be we have to find the answer in terms of y alone. That is what they're saying. So in place of x, you can write tan y. If in place of x you write tan y, what will be your answer? It will be minus 2 tan y. 1 plus tan square is sec square. Then sec square y raised to a square. Then you can just simplify this and you'll get the final answer. Moving forward. Okay, we have to verify the Rolle's theorem. Question number 65. We have our fx is equals to x into x minus 1 the whole square, and the domain D has been given to us as 0 to 1. So if you recall, I told you about Rolle's theorem. At one point between 0 and 1, f dash c, there will be a point c such that f dash c is equals to 0. This is your Rolle's theorem. Alright. And one more thing, you have to understand that it's the how should I say that you're saying that at f0 and f1 the value for fx should be the same. Okay, the same values. Then like the function started from here, went down, went up, or it can move like this, but it should come back to the same point. So f0 should be equal to f1, or it can be between any 2 points, like f 0.5 is equals to f 0.9. It can be like this. So let's see how to the question given to me was this: fx is equals to x into x minus 1 ka whole square, and the domain given is 0 to 1. Alright, simple enough. Now if I say that at 0 what is the value, so you can say 0. At f1 what is the value? Okay, 0. So you are getting the same two values. So if you can plot it, the value for at x equal to 0, value is 0. At x is equals to 1, the value is 0. Alright. So the graph is continuous. It is moving up and down. So it can move like this or any way. It can move like this. It can move like this. But still, there will always be a point, at least one point, C, where f dash c is equals to 0. Alright. So if I put f dash c equal to 0, first f dash c, so I write it as c 2 times c minus 1 plus differentiation of this will be 1 and x c minus 1 ka whole square. So 2c square minus 2c plus c square plus 1 minus 2c. C square, 2c square, 3c square minus 4c plus 1. So on putting this equal to 0, I'll get my c. So 3c square minus 3c minus c plus 1. Alright. So solving this, 3c c minus 1 minus 1 c minus 1 equal to 0. So c minus 1 and 3c minus 1. So I have got 2 points. C is equals to 1 and c is equals to 1 by 3 where f dash c is equals to 0. This is how you should implement Rolle's theorem. Moving forward, I have with ourselves question number 66. fx is equals to sine raised to the power of 4 plus cos raised to the power of 4x. And the domain D is from 0 to pi by 2. ठीक है. Again, if you see, you put the value of x is equals to 0, the answer is 1. And if you put the fx is equals to pi by 2, still the answer is 1. This is a continuous function and differentiable too. So it is satisfying all the conditions for Rolle's theorem. Now, what should I do? First, I'll differentiate it. This should be equal to 0. Now, I'm solving this. 4 sine cube x cos x minus 4 sine x cos cube x. So 4 sine x cos x. Sin square x minus cos square x is equals to 0. Alright. So this whole term can be 0. Yeah. Okay, we'll see. Either sin x into cos x is equals to 0, or sin square x minus cos square x. This is minus cos 2x. And minus cos 2x is equals to 0. So only one of these two is true. So in 0 say pi by 2, what is 0? This can never be 0 in 0 say pi by 2. You know why? See, cos is 0 at pi by 2. Alright, when x is equals to pi by 2, so at pi by 4 this is equals to 0. At x is equals to pi by 4. So x is equals to pi by 4 is a point where f dash c is equals to 0. And what more points do we have? What more points at sin x equal to 0 and x is equals to pi by 2. So these are the 3 points where f dash c is equals to 0. Okay. Now we'll do question number 67. So fx is equals to log of x square plus 2 minus log 3. Okay, the domain given to us is minus 1 to 1. f at minus 1, log minus 1 is plus 1 plus 2, 3, log 3 minus 3 is 0. And similarly for f1, 1 plus 2, 3, log 3 minus log 3 is 0 again. Okay. Alright. And log 3 will be 0. So the only way for this to be equal to 0 is x is equals to 0. So this is your c. C equal to 0 is the only point that you have got. Question number 68. So there's a function fx given to us is x plus 3 e raised to the power of minus x by 2. x square. Great. The domain given to us is -3 to 0. So on putting the value of 3 over here, I'll get a 3 into 6, 18, e raised to the power of minus, or rather, no, there's a -3. So -3 and 0, it will be a 0. And similarly for f0, it will be a 0. So that satisfies our condition for Rolle's theorem to be applicable, right? Now we just have to find the c such that f dash c equal to 0. So how can we do this? I'll just differentiate this whole term with x. So on differentiating, I can like x square plus 3x and e raised to the power of -x by 2. All right. So 2x plus 3 e raised to the power of -x by 2 and -1 upon 2 x square plus 3x e raised to the power of -x by 2. ठीक है. Two x plus 3 minus x square upon 2 minus 3x upon 2. This should be equal to 0. This can never be equal to 0. Only this part can be equal to 0. So minus x square upon 2, 2x, 4x upon 2, 2 plus x upon 2 plus 3 equal to 0. So minus x square, rather plus x square minus x and minus 6. So x square minus 3x plus 2x minus 6 is equals to 0. x6 minus 3 plus 2x minus 3 equal to 0. So x can be equal to 3 or x can be equal to -2. These two are your answers for C. Question number 69. Fx given to us is under root of 4 minus x squared. The domain D which we have is -2, say 2. So f at -2 is equals to 0. All right. F at 2 is equals to 0 again. Under root of 4 minus x squared. The minus 2x. So 2 से 2 हट जाएगा. I have a minus x upon the root 4 minus x square. Only way this can be equal to 0 is when x is equals to 0. This is your point for C. C equal to 0 is your answer. So there is a function given to us. For Rolle's theorem to be not applicable, we should either. What was the condition for Rolle's theorem to be applicable? Function should be number one, continuous. Function should be differentiable. So if the function will not satisfy any of these two conditions, then it will not satisfy Rolle's theorem. So let's check. So since these are polynomial, they are continuous everywhere, but we should still check at x is equals to 1 because the function is changing its behavior at x is equals to 1. So limit x tending to 1 minus for the function fx. We can write it as this, limit x tending to 1 minus for x square plus 1. So it will be 2. Now limit x tends to 1 positive for fx is equals to limit x tends to 1 positive for 3 minus x. it is also equal to 2. So limit exists. कंटिन्यूअस तो है. अब डिफरेंशिएबल के लिए चेक करना है, तो इसका एफ डैश एक्स निकाल के रख लो. एफ डैश एक्स हो जाएगा 2x फॉर 0x 1 एंड -1 फॉर 1x. ठीक है, तो ये भी कंटिन्यूअस फंक्शन है, ये भी तो कंटिन्यूअस, एक्स की कोई बात ही नहीं है. तो एट एक्स टेंडिंग टू 1 पे देख लेते हैं. तो लिमिट एक्स टेंडिंग टू 1 माइनस फॉर एफ डैश ऑफ एक्स इज इक्वल टू लिमिट एक्स टेंडिंग टू 1 माइनस पे यहाँ पे आएगा 2x, सो वैल्यू हो जाएगी 2. एंड लिमिट एक्स टेंडिंग टू 1 पॉजिटिव एफ डैश ऑफ एक्स पे आ जाएगा -1. कंट्रास्टिंग वैल्यूज, discontinuous. So this proves that ये जो फंक्शन है ये रोलिस थ्योरम को फॉलो नहीं करेगा. This does not follow the criteria. Find the points on the curve y equal to cos x minus 1 in where the tangent is parallel to x axis. यही तो बता रहा हूँ मैं रोलिस थ्योरम, ये उसका ज्योमेट्रिक मीनिंग है. See, that is why I ask you to go to the depth of the concept. Like उसको याद मत करो कि f dash c is equals to 0. Simple logic लगाओ. This, if I give you 2 points, okay, these are the same points. Let's say the value is 10. Let's say the value is 1. Let's say the value is 8. If your function is reattaining this value, it can definitely go like this in a straight line. So if it moves in a straight line, it is already parallel to x-axis. So that means that f dash of x is already equal to 0. But still it can move like this, it can move like this, or it can move like this. There's any way it can go. So there is at least 1 point. This is the simplest way, right? So there's still 1 point. So we say there's at least 1 point where f dash c is equals to 0. So what is the meaning for this? This is the meaning that the line, the tangent is parallel to x-axis. All right. So understand this concept. Now, in question number 71st, it is asking the same thing. Fx is equals to cos x minus 1 and domain is 0 say 2 pi. All right. At f0, 1 minus 1 is 0 and f2 pi is also 0. All right. Now, what should I do? I'll just differentiate it. Cos x is minus sin x. So wherever this is 0, that will be our point for C in this domain. So kahan pe sin 0 hai? Draw the graph. At 0, pi by 2, pi. 3 pi by 2, 2 pi. So if 2 pi is included, 0 pi, 2 pi. These are the 3 points for C. And now you can do one thing. Leave out these points. Okay, 0 and 2 pi. Leave out these points. Just take this one pi and find the y for this. Like y is equals to cos x minus 1, right? So cos pi minus 1. So it will be minus 2. The point which they are asking will be x की value pi, y की value minus 2. This will be your answer. They're asking for the point where the tangent it will be parallel to the x-axis. So you have to find the x and y coordinates. Moving forward with question number 72. Again, the same kind of question. So the curve given to me is fx is equals to x minus 4. Okay, and x belongs in 0 to 4. So the tangent is parallel to x-axis. Now, y equal to x square minus 4x dy by dx is equals to 2x minus 4. This is 0 at x is equals to 1 by 2. Now if x is equals to 1 by 2, what will be the value for y? 1 by 4 minus 2. So this will be equal to 4, 8 upon 4, minus 7 upon 4. Next up, we have question number 73. What was the mean value theorem? If you remember the Rolle's theorem, the concept for Rolle's theorem was the main difference between Rolle's and mean value is that these 2 points of the domain, they must not be the same. Okay. So what happens is the curve can go like this, but there will be some slope, right? I'll say that this slope is m. So there is at least one point on this graph whose tangent, whose f dash of c is equals to m. Basically, this is tilted Rolle's theorem. Tilted Rolle's. Why? See, in Rolle's, these 2 points were there. The slope between these 2 lines was m equal to 0, and f dash c was said to be equal to 0. Same thing happens here. Okay, you find the slope for this now m, and there's at least one point such that f dash c is equals to m. So this is what is called mean value theorem. Okay. So we have question number 73. So how to solve this? Fx is continuous and differentiable in it. We already know. We can I'll just find fx is 1 upon 4x minus 1. So I can write it as 4x minus 1 raised to the power of minus 1 upon f dash of x is minus 4x minus 1 का minus 2 and into a 4. ठीक है, तो मैंने बताया f dash c क्या होगा. f dash c will be equal to f4 minus f1 whole upon 4 minus 1. ठीक है, तो f4 कितना हो जाएगा 1 upon 16 minus 1, 1 upon 15, 1 upon 15 minus 1 upon 3, 3 यहाँ पे आ जाएगा 15, 5, 1 minus 5, तो minus 4 upon 15 into 3, तो minus 4 upon 45. ये हो गया f dash c. तो इसको अगर सॉल्व करें minus 4 upon 45, minus 4 upon 45 को f dash c minus 4 upon 4x minus 1 का होल स्क्वायर, तो minus 4 upon 4x minus 1 का होल स्क्वायर इज इक्वल टू minus 4 upon 45. ठीक है, 4x minus 1 का होल स्क्वायर इज इक्वल टू 45. 4x minus 1 is equals to plus minus 9 5s are, so 3 root 5. 3 root 5. So 4x is equals to 1 plus minus 3 root 5, and x will be equal to 1 plus minus 3 root 5 by 4. So this will be your answer. Fx is equals to x cube minus 2x square minus x plus 3. The domain D is 0 to 1. All right. So f dash c, again same thing. Now f dash c will be equal to f1 minus f0 whole divided by 0, 1 minus 0. ठीक है, f dash c कर ही लेंगे हम लोग, 3x square minus 4x minus 1 is equals to 1 minus 2 minus 1 plus 3, 0, and minus 0 plus 3, minus 0 plus 3, right? तो यहाँ पे आ जाएगा minus 3 plus 3, 0, 0, 1 minus 3, तो minus 2 divided by 1. तो 3x square minus 4x plus 1 is equals to 0. तो 3x minus 1 and x minus 1, right, is equals to 0. तो x की वैल्यू 1/3 एंड x की वैल्यू 1. ये 2 पॉइंट पे 0 हो रहा है, लेकिन डोमेन कहाँ से कहाँ है? 0 से 1. इसको नहीं इंक्लूड करेंगे. दिस विल बी योर आंसर. x इज इक्वल्स टू 1/3. वो पॉइंट है जहाँ पे मीन वैल्यू थ्योरम सेटिस्फाई हो रही है. ऑलराइट, सो क्वेश्चन नंबर 75 now. तो क्वेश्चन नंबर 75 में दिया है fx इज इक्वल्स टू sin x माइनस sin 2x. डोमेन है 0 से पाई. ओके, तो एफ डैश सीज का अगर मैं लिखूं तो cos x माइनस 2 cos 2x. दिस इज इक्वल्स टू क्या होगा? f पाई माइनस f0 पाई माइनस 0. ठीक है, तो साइन पाई माइनस साइन 2 पाई माइनस साइन 0 प्लस साइन 0 होल पाई माइनस 0. तो 2 cos 2c माइनस cos c इक्वल टू 0. ठीक है, 2 टाइम्स cos स्क्वायर c माइनस 1 माइनस cos c इक्वल टू 0. तो 4 cos स्क्वायर c माइनस cos c माइनस 2 इक्वल टू 0. तो cos c की वैल्यू 1 plus minus under root 33/8 आएगी. So these are the values which lie in 0 से pi, and these will be the answer. Now moving forward with question number 76. तो हमारा fx हमें दिया हुआ है अंडर रूट ऑफ 25 माइनस एक्स स्क्वायर. डोमेन दी हुई है 1 से 5. ऑलराइट, तो f डैश x इज इक्वल्स टू f1 under root 24 minus f5 will be 0. 1 minus 5 will be minus 4. Okay, and upon finding f dash x, the f dash of x is equals to 1/2 under root 25 minus x square, and this is a minus 2x over 8. So equating it with under root 24 upon 4. So minus minus will get cancelled out. 2. So it is x upon under root 25 minus x square is equals to under root 24 by 4. Squaring it, x square upon 25 minus x square, 24 upon 16. 8 2s are 8, 3s are 16. So 2x square is equals to 75 minus 3x square. Now 5x square is equals to 75. 525, and x is equals to plus minus 5 will be your answer. Find the point on the curve y equal to x minus 3 square where the tangent is parallel to the chord joining the points 3, 0 and 4, 1. So this is the same thing like I told you before in Lowell's theorem also. This is the geometrical interpretation of what I made you imagine by making the graphs. So let's just solve this question like we have been doing till now. So I'll just do this. F dash of c is equals to f4 minus f3 divided by 4 minus 3. All right. Now 2 times of c minus 3 is equals to 1 minus 0 upon 1. So 1, and c minus 3 will be equal to 1 upon 2. So c is equals to 7 upon 2, which belongs in 3 to 4. at x is equals to 7/2, the point of tangency which satisfies this chord wala scenario occurs. All right. Now question number 78. Using mean value theorem, prove that there is a point on the curve this between points A and B where tangent is parallel to the chord AB. Also find that point. Okay. So on finding f dash c, I have 4x minus 5 in place of f dash of x, and f2 minus f1 divided by 2 minus 1. So f2, 2, 4, 8, 8, 8 plus 3, 11, 11 minus 10, 1, minus f of 1, 1 is 0, whole divided by 2 minus 1 is 1. So 4x minus 5 is equals to 1, 4x is equals to 6, and x is equals to 3/2, which belongs in 1 से 2. ठीक है. So hence x is equals to 3/2 है, तो y की वैल्यू उस पे निकाल लेंगे. And question number 78 था y equal to 2, 9/4 minus 5, 3/2 plus 3. तो 9/2 minus 15/2 plus 3, तो ये हो जाएगा 0. तो x की वैल्यू कितनी थी? 3/2. 3/2 y की वैल्यू 0 पे जो कंडीशन है वो सेटिस्फाई होगी. तो find the values of p and q so that it is differentiable at x is equals to 1. अच्छा, सबसे पहले तो कंटिन्यूअस का देख लेते हैं. तो कंटिन्यूअस होने के लिए लिमिट x टेंडिंग टू 1 माइनस ऑफ एफ एक्स, इसकी वैल्यू डालूं अगर तो एक्स स्क्वायर प्लस 3x प्लस पी, 1 माइनस, तो 1 प्लस 3 4 प्लस पी हो जाएगी. एंड लिमिट x टेंडिंग टू 1 पॉजिटिव ऑफ एफ एक्स, लिमिट x टेंडिंग टू 1 पॉजिटिव ऑफ क्यू एक्स प्लस 2, ये हो जाएगी q प्लस 2. तो 4 प्लस पी इक्वल टू क्यू प्लस 2, तो p प्लस 2 इज इक्वल टू क्यू. एक बात. ऑलराइट, अब इसका f डैश x का हम लोग वो बना देते हैं 2x प्लस 3, यहाँ पे आ जाएगा q. ये है एफ एक्स इज लेस देन 1, ये है फॉर एफ बीइंग ग्रेटर देन 1. तो अब लिमिट एक्सटेंडिंग टू 1 माइनस पे जो एफ एक्स आएगा, लिमिट एक्सटेंडिंग टू 1 माइनस पे आ जाएगा 2x प्लस 3, एंड दिस विल बी इक्वल टू व्हाट? 5. नाउ सेम विल हैपन फॉर x1 पॉजिटिव. एफ एक्स विल बी इक्वल टू लिमिट x1 पॉजिटिव हो जाएगा, यहाँ पे q विल बी इक्वल टू q, तो q इज इक्वल टू हो जाएगा 5, देन p विल बी इक्वल टू 3. ओके. If I want to take the log out of this, let's first write the question. X raised to the power of m and y raised to the power of n is equals to x plus y raised to the power of m plus n. Okay. So if I'll take the log, I have m log x plus n log y is equals to m plus n log x plus y. ठीक है. Non differentiating both sides, it will be m upon x plus n upon y dy by dx. this will be equal to m plus n 1 upon x plus y 1 plus dy by dx. Now writing it down, m upon x minus m plus n upon x plus y. This is equals to m plus n upon x plus y minus n upon y dy by dx. So my minus nx all divided by x plus y equal to my minus nx y x plus y dy by dx. Then dy by dx is equals to y by x. This proves the first part. And now if I differentiate both sides, d2y upon dx square will be equal to x dy by dx minus y whole x square. dy by dx की value I'll put it y by x minus y upon x square. So y minus y, this will turn out to be 0. So hence we have proved both parts. Now question number 81. So if x is equals to sine t, y is equals to sine pt, then we have to prove something. dx upon dt will be cos t, dy upon dt will be p times cos pt. So dy by dx p cos pt whole divided by cos t. So this is your dy by dx. And now if I try to find d2y upon dx square, it should be cos square t is equals to p square cos square pt. Now d2y upon dx square can be written as 1 minus sine square t is equals to p square 1 minus sine square pt. ठीक है, तो y double dash 1 minus x square is equals to p square 1 minus y square. What do we have to prove over here? 1 minus y double dash. Okay, there's still work to do. Now I think we have to differentiate with respect to x as well. See, we reached till here. Y double dash 1 minus x square is equals to p square 1 minus y square. So 2 y dash y double dash. It was y dash का whole square. Okay. 1 minus x square minus 2x y dash का whole square is equals to p square minus 2y y dash. So y double dash 1 minus x square minus x y dash is equals to minus p square y, and y double dash 1 minus x square minus x y dash plus py square equal to 0 to prove. So question number 82. dy by dx if y equal to x tan x plus under root of x square plus 1 upon 2. ठीक है, if we differentiate the both terms separately, then we'll be fine. So I'll take u is equals to x raised to the power of tan x, and v is equals to whole under root of x square plus 1 divided by 2. So log of u will be tan x log of x. So 1 upon u du by dx will be equal to tan x into 1 upon x plus log x sec square x. So du by dx is equals to u times tan x upon x plus log x sec square x, and u will be x tan x raised to the power of tan x, so tan x upon x plus log of x sec square x. This will be your du by dx. And differentiating the other term, v is equals to under root x square plus 1 upon 2. So dv by dx is equals to half whole under root x square plus 1 by 2 raised to the power of minus 1 upon 2. 2x upon x. So x. So x upon 2 under root of 2 times 2 upon x square plus 1. So dv by dx is equals to x whole 2 times x square plus 1. Now moving forward with question number 83. If fx is equals to 2x and gx is equals to x square upon 2 plus 1. Okay, so then which of the following can be discontinuous function? Since these are all polynomial functions, then f plus g, f minus g, f into g, this will also be a polynomial function. These will all be continuous. So the only way which it can be discontinuous is f upon g or g upon f as it is given. So g upon f, how can it be discontinuous? X square by 2 plus 1 upon 2x. So when x is equals to 0, then this function is discontinuous. At x is equals to 0, there is discontinuity in this function. Alright. The function fx is discontinuous only at one point, discontinuous at 2 points, discontinuous at 3, or none of the above. So let's check it. So 4 minus x square, 4x minus x cube. Okay, so when 4x minus x cube is equals to 0, then it is discontinuous. So I'll take x, 4 minus x square is equals to 0. So at x is equals to 0, at x is equals to plus minus 2, this function is equal to 0. So discontinuity at 3 points. The set of points with the function f given by mod of 2x minus 1 sin x is differentiable is okay. So let's approach from the right hand side for f dash to limit h tends to 0 for f half plus h minus f half whole divided by h. 2 times mod 2 mod 2 half plus h minus 1 close sin half plus h minus 0 whole divided by an h. So limit h tends to 0, mod 2h sine 1 plus 2h upon 2 whole divided by an h. Limit h tends to 0, 2h sine 1 plus 2h upon 2 upon h. So this can be written as what, 2 sine 1 by 2. Okay. Now approaching from the left hand side for the same. The limit h tends to 0, f1 by 2 minus h minus f1 by 2. Limit h tends to 0, 2 half minus h minus 1 sine half minus h whole divided by minus h. So limit h tends to 0. Limit h tends to 0. 2 half minus h minus 1 sine half minus h whole divided by minus h. So limit h tends to 0. Minus 2h sine half minus h whole divided by minus h. The limit h tends to 0, 2h sine half minus h minus 2 sine 1 by 2. So fx is not differentiable at x is equals to 1 by 2. Alright. Since left hand and right hand limit are coming different, now the function fx is equals to cot x is discontinuous on the set. Cot x is nothing but cos x upon sin x. So wherever sin x is equals to 0, then that will be the point for discontinuity of cot x. So at x is equals to n pi for n belonging in integer z, there will be discontinuity. The function fx is equals to e mod x is this. So we know that mod x and ex are continuous functions on R. So e mod x is also continuous function on R. What can we say? Mod x is not differentiable at x is equals to 0 because the king comes. See, mod x, a king comes now at x is equals to 0. So that is why mod x is not differentiable at x is equals to 0. Okay. So if mod x is not differentiable, so e raised to the power of mod x should also be not differentiable at x is equals to 0. Alright. X square sine of 1 upon x. So that the function is continuous at x is equals to 0. So we know that fx is continuous at x is equals to 0. Okay, so since fx is continuous, the limit must exist. Limit x tends to 0 for x square sine 1 upon x. X square sine 1 upon x. Okay, this should be f0. So at f0, this will be 0 into this will be an oscillating function from minus 1 to 1, which does not matter since 0 is multiplied. The answer is coming out to be 0. So the function is 0. A part is correct. So we have done till question number 90th. And we'll take up from here in the next session. Thank you for your time.